In this video, we're going to be looking at another way that we organize our elements, and it's going to have something again to do with our groups. So let me first review some of our groups. We got group 1, 2, and if we remember, everything in group 1 has 1 valence electron, group 2 has 2 valence electrons, and moving past our transition metals here to group 13. In group 13, we have 3 valence electrons, 14, 4 valence electrons, 15, 5 valence electrons, 16, 6 valence electrons, 17, 7 valence electrons, and in group 18, we have 8 valence electrons minus helium, which just has 2 valence electrons because it only has 2 electrons. And elements that have similar number of valence electrons often have similar properties. So that's why we group them into families this way. So the first family I want to talk about is our alkali metals. This is going to be group 1 minus hydrogen. They have 1 valence electron and are very reactive. So we've seen an experiment with one of these. So let me draw a box around all of our alkali metals here. So those are our alkali metals. We got 1, 2, 3, 4, 5, 6 of them. And I'll put it up here. These are alkali metals. And they are extremely reactive. One property they all have, besides having 1 valence electron, is they all react when they're put in water. So I've shown you that reaction before with lithium. And you saw it bubbling around in water and slowly disappearing. I didn't want to bring it home because I have to store it in oil, and it floats on oil, and it's not a very good way to store it. So I don't like bringing that one home. But just know they are all extremely reactive, and you can't find them in their pure form in nature. Moving on to our next family that we're going to talk about, our alkaline earth metals. These are going to be all our elements in group 2. And like we said, group 2, they have 2 valence electrons. These are definitely less reactive than our alkali metals, but we're still going to call them considerably fairly reactive. So let's draw a box around those ones. We got 6 of them. These are going to be they got a very similar name. Something I notice students mix up often. Our group 1 are alkali metals. These ones are alkaline. So sometimes they get those words mixed up. Alkaline earth metals. So they all have 2 valence electrons, and they're not quite as reactive as our group 1. One example I have is we got magnesium here, and magnesium has a kind of an oxide on the outside. I like to consider it like similar to rust, how iron rusts. A magnesium forms a different type of oxide when found in air. But magnesium's often used as a fire starter because it's very easy to catch on fire, and you just sand a little bit off and use some steel and flint, and it's used in a lot of fire starting kits because these are still fairly reactive. The next group that I want to talk about that is a family is going to be what we call our halogens. These are all our elements in group 17. These ones are non-metals. They have 7 valence electrons, and they are extremely reactive. Very, very, very reactive. So they're going to be in group 17. So they are these elements here. We're probably familiar with some of these. Chlorine, very good at killing bacteria in water. Fluorine, we use that in our toothpaste to help strengthen our teeth and kill bacteria. So these are going to be our group 17 halogens. And they are I can't stress how reactive they are. They are extremely reactive. They want to react with something. And then the last family that we talk about in this class is going to be what I like to call, well, I guess what they're called is noble gases. And that's group 18. These are all gases. They have a full set of valence electrons. So remember, helium has only 2 electrons. They're both, that completes its full set. And the rest of them, they're at the end of the periodic table. These all have a full set of valence electrons. So they do not want to react with any element. They are not chemically reactive. So let's put a box around our noble gases. And the reason why they're called noble gases is when you think back in history to the medieval times, you could think of the nobles, and the nobles didn't like to interact with, the common folk meaning all of our other elements. They like to stay to themselves. They're not interested in what, the peasants are doing. And just like these elements aren't interested in what any of those other elements are doing. They're just, hanging out with themselves, and they're happy with that, and they don't need to be with anyone else because they have their full set of valence electrons. So these ones are called our noble gases. And what we're going to find moving into our next few weeks is each of our families have similar properties because of their valence electrons. And we're going to be talking about how those valence electrons influence how they want to react with other elements. Like our noble gases don't want any more valence electrons, so they won't react with any of our other elements. Whereas our other families here, they don't have a full set of valence electrons, so they might react or interact with other elements to get that full set. So from these notes, we should know these 4 families and a little bit about them.